Hey, hello everybody. Welcome to problem solving for lesson 10-7. We are on page 259 in your textbook. So please open that up. It's always good to have that off to the side. You can just look at it. You don't have to worry about missing any screens or anything like that. Okay. We're just doing the problem solving, and looks like there's four problems. Okay, not too bad. So let's take a look. Now remember, this lesson we were looking at how to look at whole numbers as fractions. So let's take a look at number 18. And 18 says, Declan. Here's what Declan says. To turn the whole number 5 into a fraction, so like 5 candy bars or 5 pizzas into a fraction, I just put 5 under a numerator of 1. Do you agree with Declan? Explain. Let's read that again. To turn the whole number 5 into a fraction, I just put 5 under a numerator of 1. All right. So you're going to be thinking about this, whether you agree or not, and explain if he's correct or not and why. Why don't you pause this video to do some thinking about that, write something out. Or if you're not sure exactly how to approach this, then go ahead and not pause this video and work right along with me. Okay. All right, welcome back. So, I don't know about you, but I clued into this vocabulary word numerator. Okay, so when you think of a fraction, you've got a numerator and a denominator. And one number goes on the top and another number goes on the bottom, correct? And the numerator is the number that goes up on the top. And the denominator goes on the bottom. So based on what Declan says, he says to turn the whole number 5 into a fraction, I just put 5 under a numerator of 1. So the numerator is 1, and the 5 is under the numerator. So it looks like what he has said is that this is equal to 5 wholes, or 5 pizzas. And I look at this fraction, it says 1/5 is equal to 5 wholes. Now, unfortunately, he's not correct, because 1/5 means, remember the denominator down here says how many pieces there are in one whole. So he's taking 1, 2, 3, 4, 5. The numerator says how many pieces you are describing. In this case, it's 1. So he's only 1. This is actually showing less than 1. This is just showing 1 out of 5 pieces for one whole instead of 5 whole pizzas. So I think what Declan did was he misunderstood numerator denominator, and what he should have said is I put one under the numerator of 5, right? So if he would have done that, then if he would have put 1 under the numerator of 5, that describes 5 wholes. Because now we have the denominator, which states there's only 1 piece in every whole. So that whole candy bar, that whole pizza, has not been sliced up. It's just one giant piece. And if you have 5 of these pieces, each one represents a pizza. So you have 5 pizzas or 5 things. So how you would maybe respond to this is, do you agree or not agree? Say, I don't agree to create a whole number fraction okay, one must be the denominator. And Declan said it was the numerator. So all he had to do was switch this around and say the 1 should be the denominator, 5 the numerator, and we're good to go. All right, let's move on to 19. Number 19, writing to explain. Let's take a look. What pattern do you notice in a fraction that is equivalent to 1 whole? Okay. Pattern do you notice when a fraction is equivalent to 1 whole? So I want you to be thinking about 1 whole, and how would you show that as a fraction? And then maybe split it up. How would you show that as that 1 whole thing as a fraction? Or maybe that as a whole fraction. What would that look like? And do you see a pattern there? Something that's similar that's happening. Why don't you pause the video, and think about it. And when you're ready, come on back and let's pretend to discuss it. All right, hold on there. Pause it. All right, welcome back. I'm going to bring out my handy dandy fraction strips. Love these things. And give some examples of 1 whole. There's one example. Has it been cut into anything? Just 1 piece. So we've got 1 whole, right? If I wanted to show that as a fraction, my denominator tells me how many pieces are there in 1 whole. Well, there's 1. And how many pieces do you have? 1. Okay. Well, we can also show 1 whole by cutting it up into 2 pieces, right? So the denominator would be 2, because there's 2 pieces in 1 whole. And how many pieces do we have? 2. Let's cut it up into fourths. Thirds, what the heck? 1, you need 1, 2, and 3 to make 1 whole. So our denominator is 3. And how many pieces do we have for 1 whole? 1, 2, 3. Do you guys see a pattern there? We can continue this on. I can skip it and go right to maybe eighths. I have to do a bunch of those, right? How many eighths does it take to make 1 whole? Oh yeah, it takes 8. 8 eighths. So the pattern that I see, and I'm hoping that you see, is that fractions that show 1 whole, the numerator is equal to the denominator. It's the same number. So when you're writing to explain, you could say each fraction for 1 whole, the numerator and denominator, I can't do it, are the same. Boom. For each fraction, 1 whole, the numerator and denominator are the same. There's your pattern. All right, let's go on to number 20.